All right, here we are, 1B, solving multi-step equations. One of my favorite things to do in algebra is just solve equations. The harder, the better. The more steps, the more numbers, the more variables. I love it all. I love solving multi-step equations because I really only have to remember two things. I need to remember the inverse operations and then the order of operations. So let's review. The inverse operations, and right now we really only have to work with two. By the time you leave high school, you'll probably have, if you take AP Calculus, you'll have about 5 total inverse operations. So there really aren't that many, which makes me happy. The inverse operations, anyway, that we're going to deal with today are addition and subtraction. So addition undoes subtraction, and multiplication undoes division. A couple more that we'll use by the end of the school year are a square root undoes the square, and a logarithm undoes an exponent. All right, so those are the two inverse operations that we'll need to work with today. And then the order of operations, let's review that really quickly. Order of operations. So I learned the order of operations as please excuse my dear Aunt Sally. Some teachers call it PEMDAS, and there's even new orders of operations acronyms out there, but I just stick with these 6 letters in this specific order because I think it's what we're all most used to. What does the P stand for? The P stands for grouping symbols. Whatever is in parentheses or brackets or curly braces, you have to do first. Grouping symbols. Then, if there are any exponents, you have to work with the exponents next. Exponents. Of course, if you have an exponent inside your grouping symbol, do that first. Next up is MD, multiplication and division. If you get down to a problem where it's all multiplication and division, what you're going to do is you're going to work from left to right. Left to right. You're going to multiply or divide from left to right. And then addition and subtraction, AS stands for addition and subtraction. Again, if you get down to a problem where it's just addition and subtraction, you must work left to right. You must work left to right. All right, so that's pretty much it for, the rules of the game. Let's do a couple of examples, and that'll be that for today. So here's example A. Example A looks like 6 times 2n minus 3 in grouping symbols, minus 2 times another set of parentheses or groupings, 6n plus 1, and we're going to say that this is equal to 10n. So set the equation equal to 10n. All right, that's kind of a wonky n. So what should we do first? We need to do the grouping symbols first. Inside 2n minus 3, I can't do anything there. 6n plus 1, nope, I can't add this, can't do anything there. So next up, we'll just eliminate the grouping symbols by using the distributive property. So what I'll do is distribute in the 6 right here. That gives me 12n minus 18. And then we're going to have to be kind of careful over here. This is a negative 2. Really, think of that as negative 2. Distributed in, distributed in. So if I didn't have any of this, whoops. If I didn't have the 2n minus 3, or actually it was 6 times 2n minus 3, if I didn't have any of that, I would be distributing in the negative 2, and that would give me negative 12n and a negative 2 or plus negative 2. So send that negative with the 2 as you're going about the distributing process. Okay, don't forget about equals 10n. All right, so far so good. Next up, what we want to do is combine the like terms. So as we go about the business of combining like terms, I see an n here and another n there. Stick to one side of the equation. And I see a constant of negative 18 and a constant of negative 2. Why are they constants? Well, they're constants because they don't have a variable. They don't have a letter with them. They will constantly be negative 18. There's no number that we're going to plug in for a variable and multiply it by something. That's why they're called constants. Okay, so anyway, Well, 12n minus 12n, that cancels out. Those are gone now. But negative 18 and negative 2 gives me negative 20. Okay, so again, negative 12n and positive 12n, positive and negative just cancel. Oh, I'm done there. All right, anyway, equals 10n. My last step, well, what's the opposite of multiplying by 10? That will be dividing by 10. So I'll use an inverse operation, and I'm down to n is equal to negative 2. So what's my solution? N equals negative 2. No need to rewrite that with the n first. I'm okay. I can read it like that. Okay, so if I lost you, please rewind and take another look. If you're still with me and you're good to go, let's keep moving. So here we go. Example number 2. We're going to take 2x and add it to 3 times the quantity 4x minus 1. And then we're going to set this equal to 2 times the quantity 5x plus 3 plus 4x. All right, so this is going to be a fun time. I've got parentheses on both sides. I've got lots of variables on both sides. I'm kind of happy and relieved that I only have the one variable. I only have x's. So I don't know, let's just roll up our sleeves and get her done. Inside each set of parentheses, 4x minus 1, nothing can be combined. Nothing needs to have its exponent dealt with. 5x plus 3, nothing can be done there. So we're ready to use the distributive property. I'm going to distribute in a 3. I don't need to worry about its sign because it's positive 3. I'm going to distribute in a 2 right here. Again, not worrying too much about the sign on that 2 because it's a positive 2. All right, 2x plus 12x minus 3. Are you good with that distributive property? All right, equals 10x plus 6 plus 4x. Are you good with the distributive property, 10x plus 6? I'm kind of going slow here because I tend to get in a rush and make mistakes, and then I end up with these, weird answers, like 142 divided by 17.5. I don't know. Okay, anyway, I think I'm good. I've double-checked, reworked it in my head. All right, combine like terms. So what are some like terms on the left-hand side? 2x and 12x would give me 14x. Over here on the right-hand side, 10x plus 4x is going to give me 14x. Anything else can be combined? Nothing on the left, nothing on the right. Okay, so now I need to get my letters on one side and my numbers to the other side, my variables on one side, my constants on the other side. So at this point, what I like to do is look for the smaller of my two variables. Which one's smaller, 14x or 14x? Wait a minute. Those are the same, so they'll just cancel each other out. Like if this were a teeter-totter and they were both on one side of, or both on opposite sides of the teeter-totter and they jumped off at the same time, the teeter-totter would stay balanced. Well, it would stay balanced as -3 is equal to 6. Wait a minute. No, it does not. -3 does not equal 6, and I no longer have a variable involved. So what this means is that there is no solution to this equation. And, that happens sometimes. So no solution there. But just one last parting thought. If you were to have gotten down to something that said like maybe 6 equals 6 or -3 equals -3, if you get down to something that is truly a statement but no variable, your answer will be infinite solutions. So if you get down to a variable-free or no variable statement, but it is true, then you're looking at an answer of infinite solutions. All right, so make sure that you have got all of this down. Make sure you take a picture and upload it to the document and turn it in the Google Classroom. Are you keeping your table of contents up to date? All right, good work, team.